Alright, this lesson is on parametric equations. Here we have two related variables depending on a third variable t. We have x equals f of t and y equals g of t. These are, the x coordinate is dependent on t and the y coordinate is also dependent on t. These are parametric equations. Okay, t is our independent variable and is called our parameter. Now, parametric equations can be used to separate the horizontal and the vertical motion along a curve. The third variable, t, is often time. In some cases, it is also an angle. Let's take a look at our first example. Go ahead and read that to yourself. Here we have our parametric equations. Notice our x is linear and our y is quadratic. So making a table of values. So we are going to make a table to represent the path of the curve for t from 0 to 5. So 0 to 5. Okay, so what we're going to do here is we're going to plug 0 in for t. So plugging 0 in, plugging 0 in for t, we get 0 out. Plug 1 in, we're plugging 1 in, we get 92. Plug 1 in here, we get 76. Plugging 2 in for t, just continue with that same process. Okay, notice as time increases, x is increasing, but y is increasing and then decreasing. Okay, now it says plot the points from the table onto the graph. So we want our x to go from 0 to, let's say, 500. So 1, 2, 3, 4, 5. And then our y is going from 0 up to 132, maybe a little bit higher than that. So let's go to 150. And let's go by 25s. 25, 50, 75, 100. 125, 150. Going by 25s. Okay, so we made a scale for x. We made a scale for y. Now we're going to go ahead and plot our points. So our first point is at 0, 0. 92, 76. So we're going to be about right here. 184, 120. So let's see, 184, 120. We're just approximating this. 276, 132. 368, 112. 460, 60. So notice the parabolic curve, the quadratic nature of this graph. And it makes sense. In the problem, we have a golfer hitting a golf ball. Okay. Our horizontal is going to be represented by distance in feet, and our y is going to be our height of the ball, and that is also in feet. Okay, and so that's how you make a table and a graph from two parametric equations. Okay, so here we're given a pair of parametric equations. We're given a range for t, 0 to 4, We want to make a table of values. We want to draw the graph and show the orientation, meaning where does it start and where does it end. And we want to write the rectangular equation. So let's start off here with t, x, and y. We're going from 0 to 4. Plugging 0 in. 1 minus 0 is 1. Plug 0 in. 2 plus 0 is 2. Okay, continue plugging the numbers in. Okay, so there you have it. There's our table of values. Next thing we want to do is draw the graph. So our starting point is going to be at 1, 2. 1 over, 2 up. Okay, that is our starting point. Okay, negative 1, 4, negative 1, 4, negative 3, 6, negative 5, 8, and negative 7, 10. And that point would be our ending point. So our object is moving northwest. Okay, I'm not going to put an arrow there, I almost did. Don't want to put an arrow. Arrow means it keeps going. So it's a line segment from this point to this point. And this represents a part of a line. Okay, it says write the rectangular equation. Okay, so to write a rectangular equation, you're going to solve one equation for t. Okay, then substitute into the other equation and simplify. I'm sorry about that, getting off here, and solve for y. Okay, so let's take this equation right here and let's solve this one for t. So if we solve this for t, we're going to get, subtract the 1, divide by negative 2, we're going to end up with t equals 1 minus x over 2. Okay, second step, substitute that into the other equation. So the other equation right here, 2 plus 2t. So y equals 2 plus 2 times t. T is 1 minus x over 2. Okay, and now we want to simplify and solve. So the 2's cancel. Okay, 2 plus 1 is 3. So we're going to have y equals, I'm going to put the negative x first and then the 3. And that is the rectangular equation for this line segment. Okay. Finally, how would the graph of the rectangular equation compare to the graph of the parametric equation? Well, this is an equation of a line, and lines go on infinitely in both directions, whereas this parametric equation has endpoints. Okay, so we'd say the graph of the parametric equation is part of the graph of y equals negative x plus 3, the rectangular equation. Okay, next problem. Same three things. Okay, we want to make a table. In this case, we're going from -1 to infinity. So t, x, y. That's a y. So starting at -1, 0, 1, 2, 3, and we're going to infinity, so we could keep on going, but that'll get us a good graph right there. So plugging -1 in, so -1 minus 2, -3. -1 squared is 1. Okay, so let's plug the rest of them in. Okay, and finally, when time is 3, 3 minus 2 is 1, 3 squared is 9, and we could keep going and going and going. But we do have a starting point. So let's plot this point. So we have -3, 1. So -3, 1. Okay. Notice that our horizontal is linear and our vertical is quadratic. So I wonder what type of graph this is going to make. -2, 0. Okay. -1, 1. 0, 4. That looks like it's going to be quadratic. And 1, 9. So it's going to start here. It's going to go down through that point and curve and go up. And it's going to keep going because remember, t is going to infinity, but not infinitely to the left. So what do we have here? We have part of a parabola. Okay? Alright, so we've graphed it. Let's see, do you remember the steps for finding the rectangular equation? Well, we take one of the parametrics and that's right, we solve for t. So here we're going to have t equals x plus 2. Add 2 on both sides. Okay, and then what do we do with that? Yeah, that's right, we plug it in to the other equation. So the other equation, y equals t squared. Plugging it in for t. Okay, and there we go. So what we have here is we have a parabola that's shifted 2 units to the left, which is what we have right here. And this, we could write it in standard form, but that's fine. Okay, let me make a suggestion here. Before you watch any more of this video, go ahead and pause the video right now and make this table. Okay, so what you should have noticed was that when you tried to plug in a negative number in for t in either equation, you got an undefined or an error because you can't take the square root of a negative number. So negative numbers will not come into play here, even though we're going from negative infinity to infinity. Only the positive t values and 0. Okay, go ahead and pause the video and graph it. Okay, this is what your graph should look like, and it's part of a line. Okay, finally, let's go ahead and figure out what the rectangular equation would be. Again, pause the video, figure it out, and come back. Okay, so notice I went down and I've got the square root of t equals x minus 4. So rather than squaring this, I just decided that since the other equation has the square root of t in it, I would just solve for the square root of t. The square root of t is equal to x minus 4. Plug x minus 4 in for the square root of t. You get x minus 4 minus 4. Y equals x minus 8. Now notice, linear. Important note, notice our parametrics. We might have guessed that our graph would have been square root or quadratic, but it came out as being linear.